Okay, so first, we'll see one of the problems that we have with the with our implementation, right? That's it's all inside of main, right? We'll see that's going to be an issue, right? If we want to be able to test this, we can't. Main is only it only executes from the command line, right? Somebody types in Java and then the name of the program. So it's, there has to be an actual human, right, typing this, or clicking on the arrow button to execute main. There's no way for us to programmatically execute the program, right? And see that if we send 2 + 2, it is indeed 4. There's no way for us to programmatically do that, right? It's all embedded in this function, which we can't even call, right? We can't even decide to do this. So let's look at what is it that we could do. In particular, try to identify what the model is, right? The model, we mean what? The model we need to identify what is the data, what is the raw data that we are working with, and also any operations that go along with that data, yes? Presumably, if this is a calculator, the raw data presumably is either an integer or a pair of integers, right? And the operations are add, subtract, multiply, divide, and whatnot, yes? So that makes the overall representation of what the model is, and let's see if we can extract that and represent it formally, yes? So let's look at that, extracting a model. So what there's several issues with our implementation. So one of them is that it's embedded in this main method that we can't call, we can't manipulate programmatically. Another issue is that is fully dependent on interacting with an actual human being, right? It's using as an input and output. It's using system in, system out, yes, and those specifically go out to interact with the console. Yeah, so we need to look for ways that we can rip that out and somehow be independent of dealing with an actual human being, right? That we can simulate that somehow, right? That we're no longer dependent on humans. That we can simulate a human actually typing, so we can create dozens of automated tests so that we can simulate the typing of 2 + 2, right? And validate that indeed it's 4 without somebody actually typing 2 + 2. So yes, also the arithmetic is also embedded. It's hard-coded inside of our main, right? The 2 + 2. It's not abstracted into a method like add or subtract. They don't exist. Right? So let's look at extracting all that out, right? So here's our first attempt at creating a model. Where we're going to encapsulate in one place. We're going to encapsulate, all our operations, any data that we might be interacting with, right? So integers, add, subtract, multiply, divide. All the arithmetic would be embedded inside of this one class. Yes, we're not going to implement everything. We're only going to focus on just one. Right? Again, we're going to try and keep it as trivial as possible. So this is the simplest model possible. We only have one operation, add, but obviously we can extrapolate the idea that this would have, we would host in this model. We would host all the operations would be here. Yes, whether it's a binary operation or say a tertiary operation or unary operation would be all hosted in this one class. Okay, all right. So this is our model. Also, looking forward and trying and predicting that perhaps this might not be the only implementation. All right, we're with having mock in mind, we're going to foretell that perhaps we're going to replace this implementation with some other model, right? Some other implementation. Remember last week we were thinking of a duration using 1 integer or using 3 integers. Remember that? Same thing here, where we might decide that, hey, let's do some other implementation, right? So foretelling that perhaps we're going to provide different implementations, we're going to provide an interface called SimpleCalc that only has the add function, and this particular calculator implementation is just that. It's just one specific particular implementation out of our interface. There could be more implementations, right? Although I'm not sure how else would you add. But nevertheless, right? If we have things such as matrix multiplication, or we have all sorts of really complex operations, then you could perhaps say, ooh, I have a better way of implementing matrix multiplication, right? And you have one implementation, I have my own, and we could compete in the market. So here's our model, our calculator model, trivial model. And so now we'll replace our original implementation where we are still scanning. We're still reading from the command line. Yeah, we're still retrieving the two numbers from the command line. So that hasn't changed. And our main is, but instead of hard coding the addition right here in the output, we're going through our model, right? We're going through our model instead. Right? So basically what we've done is we've abstracted this very specific low-level hard-coded code here. We've abstracted it out into this add function, right? Now, at first sight, it doesn't seem like that has bought us much, right? It says, okay, well, whatever. I mean, you just replaced an addition and just renamed it inside of this add function. What does that buy us? Well, what it buys us is that now the actual arithmetic, the algorithm, right? The actual algorithm of addition, right, is no longer hard-coded in here. Right? It's no longer hard-coded in here. Instead, it's wrapped inside of this abstract function or method called add. And now I can actually test it. I can say, ooh, I can now, without actually having human interaction and passing us 3 and 4 and 2s and providing out all these integers, I could, independently of a human being, I could test and verify that indeed 3 plus 4 is 7, and 5 plus, 17 minus 5 is indeed 12. Regardless of this main function, regardless of this human interaction, I'm no longer tied, right, to this human having to provide data for me. Make sense? Right? I know, and so now I can write tests. Before, there was no way for me to go into main, right? There was no way for me to simulate the input coming from the console or reading values from the console, right, and validating that these values were true. So what this buys me is that I am no longer, in that particular sense, at least the algorithm of my model is no longer embedded and hard-coded. I can test it independently of my main. Make sense? Right. So at first it doesn't quite seem like it buys as much, but again, our focus is can we test? Can we test? Right. Going forward, that's going to be our mantra. So yeah, so it's outside main. We can test it independently. So now we can write all sorts of automated tests, right? I can write all sorts of a test suite, right, that validates that my algorithm is correct. However, the implementation of add here, I can validate it with the expected and the actual. Obviously, we're using a trivial algorithm that only adds numbers, but you can extrapolate this a little further and say perhaps my function, my method that I'm testing is some fairly complex algorithm. Yes? Right? And instead of having it hard-coded, I can now embed it and I can test it independently. Right? So again, don't be don't be too focused on the fact that it's just a plain old add, right? But the principle still applies. Yes.
It doesn't seem like we're using the interface at all. You've just been creating instances of the underlying.
Right. Exactly. We haven't yet needed the interface whatsoever. Right. Later on, we'll consider implementing a different implementation of that calculator, right? It'll be a weird implementation, which won't actually add. It'll do something completely different. But trying to resolve that second test, there's two things that we're trying to test, right? The arithmetic part, right? But also whether the inputs are actually making it to the model correctly, right? And we'll see that our particular implementation, not of the model, but of the controller, we'll see that there's some tests that there are things that our particular controller is not considering that might munge up or distort the input somehow on its way to the model. on its way to the model, we could do some inconsistency with the inputs, and we'll see that our particular test would not be able to catch that. Right? So we'll deal with that in a minute. Yeah, we'll look at a different implementation of the model. Yeah, right now we haven't had any use for it. Also, in particular, I think a better name for this might have been that the interface was called calculator, right? And the model here was called SimpleCalc, right? Because we're going to have multiple models, right? A SimpleCalc, a complex calc, a different model. So I think maybe the namings here might better be swapped. Yeah. So right. So our intent is that we want to replace. We don't want to rely on human beings being present, and we can run hundreds, thousands of repeatable tests, right? That humans are not reliable; they can't always reproduce the same behavior.